Mirrors, practice problem number 1. As I die. All right, so you have a student that is 25 centimeters in front of a plane mirror. So the student is the object. So the DO is 25 centimeters. So I'm going to call that 0.25 meters. Okay? And we want to know, where is the image? Well, if this is a plain flat mirror, right? If it's a plain flat mirror and the person, okay, that's not a person. It's like not even a molecule. Oh, maybe it's a fat person. There we go. With a long neck. Okay, pregnant person. Okay, anyway, here's the person, right? And their image forms behind, I don't even know that I could do that again. There we go. I did. Okay, forms behind the mirror. So if they are 25 centimeters away in front, then their image is 25 centimeters away. So in part A, it asks, where is the image? It is, you can either say it's 50 centimeters from the object, or you can say it's 0.5 meters from the object. I don't really care. It doesn't matter. Then part B says, what is the magnification? Okay. So to know the magnification, I would have to know the height of the image or the height of the object or something like that, right? So I think first thing I need to find, I know that DO is 0.25 meters. So then based off of this, I know that DI is also 0.25 meters. Okay. So I can find the, let's see, I can not record this. That's basically what I need to not do. Does it say how tall the image is, the object? Oh, it doesn't. Well, so let's see. So the magnification is negative DI over DO. Yeah. So the DI, it's behind the mirror, so it's negative. So negative of a negative is a positive, right? So then that's 0.25 meters divided by the DO, which is 0.25 meters, which equals 1. So the magnification is equal to 1. So then it asks, classify the image as real or virtual. So if the image is formed behind the mirror, then it is virtual. We want to know if it's magnified, the same size, or reduced. It has a magnification of 1, so it's the same size. And we want to know if it's upright or inverted. Well, plain flat mirror, images are always upright. So that's all you do, okay? So let's find one that's maybe a little bit harder than that. Let's see. I like concave mirrors. They're the hard ones to me. Let's look at number 7. I'm going to set up number 7 for you. There we go. So number 7, you have a 10 centimeter tall candle. Oh, I also wanted to point out one other thing. Like if you look at the formulas, it doesn't matter if you use meters or centimeters as long as you use all the same thing. So you can leave everything in centimeters if you want. It really doesn't matter because as long as you use all the same one, your magnification, your units will cancel out anyway. And that's really the big thing anyway. So, so just stick with all the same unit. So let's see. So we have a 10 centimeter tall candle. So the height of the object is the candle, is 10 centimeters. That's not, there we go, centimeters. All right. And then it says it's placed 100 centimeters in front of a concave mirror. So DO equals 100 centimeters. And we want to know, let's see, we have an image forms 30 centimeters in front of the mirror. So DI, the distance of the image, it's in front of the mirror, so it's positive DI. So that's going to be positive 30 centimeters. You want to know, A, what is the focal length? Well, you have DI and DO. So let's see, we have 1 over the focal length is 1 over DI plus 1 over DO. So the focal length is going to be 1 over DI plus 1 over DO, and then you just invert it. So that's not too hard. So set that up for you quite nicely. And then part B, you want to know how tall is the image. Well, if you know DO, DI, and HO, you can find HI. So for that one, you would use HI over HO equals negative DI over DO, right? And you're basically just solving for HI, so you can multiply both sides by HO. So then HI is negative DI times HO over DO. That's it. Woo. And then for part C, you want to classify the image as real or virtual. Well, we know that the object is formed in front of the mirror, okay? But we don't know, by now you'll know if it's further or closer to the focal point, so you can figure that out. But what I like to do is I like to look at the sign of my HI. So if I have a negative times a positive, this is going to be positive, and this is going to be positive, and this is going to be positive. So if you have a negative in the formula, when you have positive times positive over positive, you're going to end up with a negative number. So you're going to end up with a negative HI. If you end up with a negative HI, it's inverted. The only images that are ever inverted are real. So I kind of go backwards. I look at the sign of HI, and if HI is negative, okay, this is going to give you, it'll be, so it will be a negative HI. So if it's a negative HI, that means it's upside down. So I know it's inverted, and I know all images that are inverted are real, because real images are only ever inverted. And then all I have to do to figure out if it's magnified or reduced is look at the number of HI compared to HO. So if your HI ends up being more than 10 centimeters, it's magnified. If your HI ends up being less than 10 centimeters, then it's reduced. So then you just look at the numbers. So you have to figure out that on your own. Okay? So I've set up a hard one and did an easy one for you. You should be good to finish the rest of that worksheet on your own.